Good morning. This is the Unit 3, Day 3 notes, and they're asking us for the angle between BA and BC, or this angle right here at angle B. So remember we have a formula. This is cosine of theta equals, and we use the dot product of BA dot BC over the magnitude of BA times the magnitude of BC. Remember to take the cosine inverse of both sides to find theta. This is pretty similar. It says find the measure of the angle between two lines instead of these points or vectors. We're going to use the same formula. We have A and B. So vector A dot vector B over the magnitude of A. I'm just going to use one line instead of two, times the magnitude of B. Remember that when we do the dot product, this is multiplying your A1 times your B1 plus, and then your A2 times your B2. That's a 2. Over, remember this magnitude is we're kind of using the distance formula. So it's going to be the square root of, and then we're going to, so I'm going to just write down the magnitude of A and B. Let's look at an example when we have two lines. Write in slope-intercept form. This is going to be my first step. This means y equals a number, our slope, times x plus b. Okay, so right here we have 2x plus 3y equals 9. I need to solve for y. I'm going to subtract 2x. I'm going to divide every single thing by 3. And we get y equals negative 2/3 x plus 3. I'm going to do the same thing for this one. It'll be easier. Y minus 3x equals 2. I'm going to add that 3x to move it to the other side. So we get y equals 3x plus 2. All right, my second step is going to be to write the slopes as a direction vector. So this slope is negative 2 over 3. And I'm going to say u, this is going to be my vector, is, and remember we put the x's first, and the slope has the y's on top. We go up first over the x values. So they're going to switch positions. So it's going to be 3 and then negative 2. And then I'm going to do the same thing for v, or the next vector. It looks like we're going to go up 3 over 1, and we put our x values first, so that is 1 and 3. My third step is just to plug it into the formula. So we have cosine of theta equals, and it is the dot product of the vectors. So 3, negative 2, and dot 1, 3. Oops. I always do the fraction. All over the magnitude, which is the square root of 3 squared plus negative 2 squared. Remember to use parentheses. Times the magnitude of 1 squared plus 3 squared. This is going to be 3 times 1 plus negative 2 times 3 over, this is 9 plus 4 square root of 13 times the square root of 10. Three times 1 plus negative 6 is negative 3 over the square root of 130. Just leave it as a square root of 130. And then we're going to solve for theta. We have cosine of theta equals this. If I want to solve for theta, I have theta equals the cosine inverse of negative 3 over 130, square root of 130. Just write this into, put it into your calculator. Make sure you do the second cosine, and we should get theta. Our angle is about 105 or 74.7. Try it out and let me know if I'm right. Okay? That's what we wanted. All right, guys, I want you to try example 2. Try to do it exactly the same way. I just wanted to put this over here so you guys can remember that the slope is always rise over run. So we go up first, which is the change in y's, which is I put b, over run, and I put a. But when we do the direction vector, we always put the x's on top, or a, and then over b. Okay? Try number 2 out. Particular case of the perpendicular. So note that 2 lines are perpendicular. They're gonna ask you this a lot. When cosine of theta is 0. Thus, if 2 non-zero vectors are perpendicular, then we only can have 0 when the numerator is 0. So when we say the numerator is the dot product. So when the dot product equals 0. Because the cosine of theta is the dot product over, oops, there you go. And we want to know when the numerator is equal to 0. So let's try this. Find t, we don't have this value, such that a and b are perpendicular. So we know that this is going to be perpendicular when a dot b is equal to 0. Okay. So a is -1, 5, and b is 2t, and the dot product is -1 times 2, plus we add them, 5 times t, and we want this to equal 0. We want to know when this equals 0. So -1 times 2 is -2. Plus 5t, when 5t equals 2, and when t is equal to 2 over 5. All right, let's try this one. This looks a little bit more complicated. It says find t such that a and b are perpendicular. Okay, same thing. The dot product has to equal 0. So t and t plus 2 dot 2 minus 3t t has to equal 0. So let's find out. t, 2 minus 3t plus t plus 2. Distribute those. We have 2t minus 3t squared. T squared is a plus, and the t's look very similar. Plus 2t equals 0. Alrighty. I see negative 2t squared plus 4t equals 0. And then we just solve. So factor out a t, maybe a 2t. And I'm left with, I'll factor out a negative 2t, so I'm left with t minus 2. Alrighty, that's when t equals 0, and when we move that 2 over, t equals 2. These are my two answers. Not too bad. So now we're going to look at how the 2D compares to the 3D and how our formulas are going to change. Usually in the 2 dimensions we have an x and a y axis, and in the 3 dimensions we have a, let's say that this is your x right here, our y, and our z. So usually, and this is going to be right here, 0 is the origin. Still. So x, we can go over maybe 2 units on the x-axis. We can go over 1, 2, 3, 4 units on the y-axis, and we're actually going to go up on the z-axis. So maybe like this. Okay. We know in the second dimension we just go to the right and up or down and to the left. So this point right here is going to be x, y. Well, just the same. This point right here is going to be x, y, z. Let's keep going. Let's look at how the distance formula changes. Usually it's x minus x squared plus y minus y squared, then take the square root of it. Now we have x minus x squared, y minus y squared, and then we're going to have z minus z squared. The midpoint, we're just going to add on to that, and it's going to be z1, since they started with the first one, plus z2 over 2. Our vector, instead of just being xy, now it's going to be xyz. Okay. AB let me see, keep going. Okay, so if they said in the last page it's A and B is this, then AB, the vector, is going to be x2 minus x1. So x2 minus x1, right? If we have A and B with 3 dimensions, then we're going to have AB is still x2, oops, minus x1, and still y2 minus y1, b minus a, and we're going to have z2 minus z1. It follows the same pattern. Magnitude is kind of like the distance formula. U squared, u1 squared plus u2 squared plus u3 squared. Same thing. Algebraic operations are going to be similar. I don't think there's anything for us to fill in here. It's pretty much the same. Unit vectors is going to be 0, 0, 1 for k. Now we're going to use I, J, and K. So this one, it says if A1, I, and A2, J, right? This one, A1 is I, A2 is J, and A3 is K. Our scalar dot products, or our last one, we have AB. A dot B is A1 times our B1, A2 times our B2, and plus A3 times our B3. Just add them. Alrighty guys, so let's try an example in 3D. It says find the coordinates of the midpoint of side BC. So remember our midpoint, put mid or something because M is slope. Midpoint of BC is going to be 0 plus 4 over 2, and then 4 plus 2 over 2, and we have one more. Negative 3 plus 1 over 2. We're going to simplify this, make it a fraction. 4 over 2 is 2. We have 6, so 3. And we have negative 2, so negative 1. That's it. What are the lengths of side BC and the median AM? So let's find the length of side BC first, or the magnitude of BC. First, I need to find BC. So BC is, remember it's C minus B. So C is 4 minus 0, 2 minus 4, and 1 minus negative 3. Four, negative 2, 4. Now I can find the length of it, or the magnitude of that vector, which is 4 squared plus negative 2 squared plus 4 squared, which is something. Let's see, 16 plus 4 plus 16 is, let me just put that, 16 plus 4, remember that's always positive, plus 16 is maybe 36. Okay. That's it. They also asked us to find the length of a median AM. So I drew a triangle. We found the midpoint of BC. Okay, and we want the length of this vector AM. So AM, this vector, I need to first find AM. I don't know why I keep on putting B. Okay, equals, remember this is M minus A. We found M, 2, 3, negative 1, minus A, which is 1, 7, 2. So 2 minus, this is M, 2 minus 1, and then 3 minus 7. And I have one more, negative 1 minus 2. All right, this is going to be 2 minus 1 is 1, negative 4, and 3. Negative 3. And now they're asking us for the length, so we have to use this formula again. So this is the square root of 1 squared plus negative 4 squared plus negative 3 squared. And we know that this is a square root of, if we add these together, this is going to be 26. Make sure I'm right. I'm going to leave it like that because it's not nice. There you go. That's it. This is the length of AN. Calculate the value of the scalar product BC dot AM. Therefore, the value of the scalar product BC dot AM. Therefore, what kind of triangle is it? So, BC, we know, is 4, negative 2, 4. 4. And AM is 1, negative 4, negative 3. And when we do that dot product, we get 4 times 1, negative 2 times 4, I'll just write it out actually, negative 2, negative 4, plus negative 4, negative 3, which is 4 plus 8 plus 12. Eight, 24. Oh, look. So we have, this is 4 times 3. This is positive. So this is negative 12. But 12 minus 12 is 0. That means that we have a right angle, 90-degree angle right here. This is perpendicular. We know that this side is equal, and we know that M is the midpoint of BC. So this is side, angle, side. We know that these two triangles are congruent by side, angle, side. CMA and BMA. So that means that this hypotenuse is going to be congruent to this hypotenuse because of CPCTC. So we know that this is an isosceles triangle. So the big triangle, triangle ABC, is an isosceles triangle. Okay, so I just drew this triangle. It says if A, B, and C are vertices of a right triangle. We know that a right triangle has a 90-degree angle, and that means that these are perpendicular. I drew the triangle so we could see that vertex B is the one that has the 90-degree angle, and that's important. So BA is a vector and BC is a vector. We need to find these vectors. BA, remember, is A minus B. So this is 4 minus negative 1 2 minus 5. And since we have the third dimension, we have -1 minus 2. Okay, this is 5 and -3. -3. BA is this vector. Now let's do BC. BC is C minus B, which is 3 minus -1, -3 minus 5, and C minus 2. We don't know what C is. That's what we're going to try to find. Which is equal to 4, -8, and C minus 2. Remember, the dot product of these has to be equal to 0. That's what we want when we have something that's perpendicular. This is when the dot product of BA dot BC equals 0. Now we have BA and BC. So BA, which is 5, -3, -3, dot BC, which is 4, -8, and then C minus 2 has to equal 0. And we do the dot product. This is going to be 5 times 4 plus, and then -3 times -8 plus -3 times C minus 2. It has to equal 0. I would just simplify this. We know this is 20 plus +24 plus, distribute this -3. So we have, instead of plus, I'm going to make this minus 3C plus 6 equals 0. Combine your like terms. We have -3C plus 50 equals 0. Subtract your 50, -3C equals -50. Divide by 3, C equals +50 over 3. And this has to be what C is in order for them to be perpendicular. I want you guys to try the other one. It's pretty simple. You're just going to use the formula. And if you have any questions, let me know. Have a great day.